In this video, let us know about nuclear forces in brief. Since this video is one of the series in foundation course in physics, I'm not going to give a deeper understanding of nuclear forces, but I'll try to give an outline of what is nuclear forces. For foundation course in physics, all the topics are taught in a lighter way or a small glimpse is given. This video is also made in such a way. First, let us start, where does this nuclear force exist? As the name suggests, the nuclear forces exist inside the nucleus of an atom, and it is one of the fundamental force existing in nature. There are four basic fundamental forces. There are many forces, but those forces come under four fundamental forces. Among that four fundamental forces, nuclear force is the basic force that exists between all the nucleus of an atom. These forces are first described by the Japanese scientist Yukawa in 1935. We all know an atom consists, the central part of an atom is called as a nucleus, and this nucleus holds protons and neutrons. We all know these protons are positively charged particles, and neutrons are neutrally charged particles. So inside the nucleus, these protons and neutrons stay together because of this nuclear force. So the force of attraction that holds the protons and neutrons together inside the nucleus are called nuclear forces. And the nuclear force is a strong force, and it is an attractive force. Next, let us see some of the characteristics of nuclear forces. So among the all fundamental force that exist in nature, nuclear forces are the strongest of all the forces that exist in the universe. And this force is found to be 1,000 times stronger than the electromagnetic forces. And these forces can act only inside the nucleus. See, outside the nucleus, they don't have any power. And these forces are charge independent forces. Charge independent in the sense, regardless of the nature of the charge, be it the positive charge or the neutral charge, the force will be the same. See, the same force will act between a pair of proton and proton, a neutron and neutron, and a pair of neutron. So they are charge independent. The affected particle is the nucleus. That means only the protons and neutrons inside the nucleus gets affected. The particle outside the nucleus do not get affected by these nuclear forces. And these forces are by the carrier particle or a field particle called pi mesons. So this proton, 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 neutron, neutron, neutron exchange their nuclear forces by means of a field particle pi mesons. And the range is very, very short. They are called short ranged forces. Because we know the size of the nucleus is around 10 to the power of minus 15 meter or 1 Fermi. So that is nothing but it is almost the diameter of equal to a proton. So they can act only between a very shorter distance of 10 power minus 15 meter. And they are spin dependent. And they are also non-central forces. These are some of the characteristics of nuclear forces.